Hello everyone, welcome you all in my YouTube channel. I am Dr. Mohammed Siraj Al Faisi, Assistant Professor, Department of Chemistry, Langat Singh College, Muzaffarpur. Today in this video, I am going to explain about types of transitions. This is a subtopic of UV visible spectroscopy. So in this video, I will focus only on transitions. What types of transitions possible in organic chemistry. So you know that in organic chemistry, sigma, pi and non-bonding present in almost all molecules. So there is a transitions like that sigma and sigma star, pi star, and non-bonding to pi star. So there are four types of transitions. Here I am showing three, but n to sigma star also possible. So out of four, two transition is very important. Pi to pi star, n to pi star. Why? You know, this is the energy level diagram. You see energy. Sigma star and sigma. There is a large energy gap compared to pi star and compared to n to pi star. So you also know the energy inversely proportional to wavelength. So n to pi star is less energy and higher wavelength. Pi to pi star in comparison to n to pi star, larger energy, shorter wavelength. And this one is huge energy, so you will not get this type of transitions in UV visible spectroscopy. So this one is more important, pi to pi star, n to pi star. Now this is the longer wavelength and this is the shorter wavelength. So remember the energy gap and also remember the inversely relationship of wavelength, because that part is very important concerning to UV visible spectroscopy. Then you can easily assign which peak belong to which transitions. If you know the transition energy, then only possible you will assign the peak. Otherwise very difficult to assign which big peak or which band in UV visible spectra belongs to n to pi star and which belongs to pi star. Again, I am going to show you these four transitions. As I told you, sigma, sigma star. So here is bonding, anti-bonding, and this one is non-bonding. This electron is non-bonding. So here is one concept. N to pi star is not possible. Sigma star, pi to pi star, n. So you see the transition sigma to sigma star, n to sigma star, pi to pi star, and n to pi star. So these two transitions is our focusing point. These transitions have large energy gap and this one is a small energy gap. Out of two, pi star larger energy gap and N2 pi star shorter. So again, on the basis of bonding, just keep this thing in your mind. Bonding, bonding, and non-bonding, anti-bonding, anti-bonding. BBNAA. So on the basis of that, this is energy level diagram. You can write only transitions. Which transitions have larger energy, you can arrange it. You can see this less energy. Now this one and this one and this one. So of course this one is larger energy. So accordingly you can arrange it. Again, here is these are normally empty. Most of the time this portion and this part pi star and sigma star, all the time it is empty, and this non-bonding always present here lone pair. So if any functional group they don't have lone pair, so in that case this will be empty. Means in case of alkene there is no double bond, alkyne there is no double bond, conjugated alkene there is no double bond, alkane there is no double bond and lone pair of electrons. So if it is in alkene there is no lone pair of electron actually. So if it is not lone pair of electron in any functional group, then this portion will be empty, and this contains bonding. So here is always you will get the electrons. So in alkene and alkyne there is a presence of double bond but no lone pair of electron. So what does it mean, the energy level? Why we are focusing on this point? That is important. So energy absorptions, and this one is the level 6, 5, 4, 3 and 2 level. So you see this one is red and this one is green, this one is blue, this one is violet. Why this color? Because you know this is the shorter energy gap, low energy gap, higher wavelength, that is red. This one is large energy gap and shorter wavelength. You see the violet. So this concept also keep in your mind. So sigma sigma star in alkane, because and almost all compound contain single bond. Pi pi star in alkenes, carbonyl compounds, alkynes, azo compound, and so on. N2 sigma star in oxygens, nitrogen, sulfur, halogen compound, and N2 pi star in carbonyl compound. This is the energy level diagram. Now, if you focus on energy and you can increase the conjugations, so this is the ethene pi pi star. So this is energy gap. Now if you increase the one double bond in buta 1,3 diene, so this energy gap become less. You see, so what will happen? Increase the wavelength. That's why in ethene larger energy gap, shorter wavelength. Here less energy gap, larger wavelength. Now what is the concept of Homo and Lume? Highest occupied molecular orbital and lowest unoccupied molecular orbital. You see, if we have ethene, so in the ground state this is the situation of electrons, and if you shine light on the molecules, this electron jump to higher energy level, and this is the excited state. So what does it mean? What happened in the gap of Homo lumo? You see here, this is the Homo and this is the lumo. Lumo part is always empty. Homo is filled. So on light it undergo higher, then it become the Homo, and this energy level become the lumo. You see clearly this and this, these portions from here start lumo. That's why highest occupied molecular orbital, this is the highest occupied, and lowest unoccupied, this is the lowest unoccupied molecular orbital. Now what is the meaning of singlet and triplet transitions? You see here, this is the energy gap. If shine light on this electron will go on higher energy level. So this is the transitions. So if it is like that, and if rotate, then it become triplet. You can see when UV visible light is absorbed by a molecule, a pi electron is moved to higher energy level. This is 2 electron here, this energy. So this type of transitions in the presence of light, we are seeing pi to pi star transition. We did it pi to pi star. So what types of transitions present this hump and this hump? This is the band, this is the band, this peak, this peak. So I already told you pi pi star and n to pi star. N to pi star have shorter energy, then it will come longer wavelength, and pi pi star larger energy, so it come shorter wavelength. Now difference between height, it is also very important. I will discuss in next video. That one is important because